All right, so we're going to do an example where we look at graphing this cotangent function based on shifts. So horizontal shifts, vertical shifts, all of those good things. So the first thing that I want to do is remind us of the basic function, the basic cotangent function. So we're going to sketch a graph of the basic cotangent function. Okay. So remember that the cotangent function is undefined at 0 and pi, so it has what's known as vertical asymptotes at those values. Okay. And then between those values, it has that kind of funny curvy shape. It has period from 0 to pi, and then that just repeats over and over and over again. Okay. So here's our basic function shape. Looks like this. And what we're going to do is think about how we can graph the transformed function. And a little bit of a shadow there. Oh, that shadow is me. Good. So I've been playing around a little bit with lighting, trying to figure out the best lighting for you guys to see these videos. Clearly, it's still not perfect. All right. So let's think about what we've done to this cotangent function. Now, I see 1, 2, 3, 4 things that are different, right? We've got this factor, this factor, this factor, and this factor. So each one of those is going to represent a different transformation. So we've got vertical stretches and shrinks, horizontal stretches and shrinks. We've got horizontal shifts, so shifting it left and right, vertically shifting up and down. We can also reflect across the x-axis, reflect across the y-axis. So let's look at each one of these and see if we can figure out what it represents. Okay, we're going to work left to right just for fun. All right, so here, this plus pi over 4, this plus pi over 4, it's inside with the x, so it's going to represent a horizontal shift. Plus actually means we're going to the left. So this means our function has been shifted left, pi over 4. This multiplier is inside again with the x, so just like this represents a horizontal shift, this multiplier represents a horizontal stretch or compression. So this is a horizontal stretch or compression, okay? And it's going to change our period, and we're going to talk about how it's going to change our period here in a minute. This 3 is a multiplier outside, so it's going to represent a vertical stretch. And last, this plus 2 is again outside of our x component, so it's going to represent a vertical shift of up 2. Okay, we don't have an x-axis reflection or a y-axis reflection in this one. If we did have an x-axis reflection, we would have this positive would be a negative. So this would be a negative to represent an x-axis reflection. Then there'd be a negative in front of our horizontal multiplier here if it was a y-axis reflection. All right, so let's see if we can take all of that and sketch a graph. Right, I'm going to pause for just a minute and mess with the lighting to see if I can get it a little bit better. Sorry, guys. All right, I think maybe that's a little bit better. Okay, so when we go to graph this thing, the first thing that we're going to want to do is think about the period. Okay? Remember, our horizontal stretch or compression, this horizontal piece is going to affect our period. So to find our new period, just like we did with our cosine and sine graphs, we take the original period of the cotangent function, which was pi. This originally had period pi, and we divide by this. Okay? We divide by that horizontal component. Okay? That means our new period is going to be pi over 2. Another way of thinking of this is this 2 means that in the original 0 to pi period, we're now going to see 2 of our repetitions repeated. So we've shrunk our period down. Okay? So our period is pi over 2. So originally, our period, before we shifted anything, of this graph would go between 0 and pi over 2. Let's think about what that's going to mean for our transformed graph here. Okay. Now, before we shifted anything, this factor of 2 means that we've taken our original period, which went between 0 and pi, and we've shrunk it down to 0 and pi over 2. Okay. So we've got one little period right here. But we've also done some other things here. In particular, we've shifted this pi over 4 units to the left, okay? And it turns out that that's also going to shift our period pi over 4 units to the left. So we had a period here. We're going to shift that pi over 4 units to the left. That shifts this side of our period to here. And this side, which was at 0, over here to negative pi over 4. Okay, so one repetition of our graph is going to occur inside of here. Now, the other thing that we've done is we've shifted and vertically stretched, but shifting vertically and stretching vertically is not going to impact these vertical asymptotes. Okay? So now what I'd like to do is we're thinking about kind of working with this guy right here. So let's see what happens to this particular point right here, right? When we have this point right here, which is at pi over 2, 0, we're going to do some shifting, right? We're going to shift this point pi over 4 to the left. So that's going to go right here to pi over 4. And we're also going to shift it up 2. So somewhere kind of inside of here. So when I go to draw this little graph, you're going to look something like this. He's been shifted up and over, okay? And then I'm just going to continue to draw repetitions. Man, I'm real bad at drawing these. I'm sorry. Just remember, I expect the same kind of awesome drawings from you. It just gets worse and worse. Okay? So the big thing here is we've shifted our period and compressed our period. And we've also moved kind of the starting point here over and up. Okay? All right. Even though it's not going to be super pretty, we're going to go ahead and look at this on Desmos and kind of compare the Desmos graph to our graph. Okay. So I'm going to share my screen here, and we're going to take a look. Okay, so our original graph here, the cotangent graph, we have shifted this to the left pi over 4, up 2. We've stretched it vertically by 3, which doesn't really impact our graph that much. And we've also done this horizontal factor of 2, which has compressed our period. Okay. All right, whew, that's hard to see, so I'm going to take this off. But if we zoom in a little bit, we can definitely see that our period is now from negative pi over 4 to pi over 4. So we've got this point up here. So I think we did okay for a sketch. And again, that's kind of the level of sketching that I'm expecting from you. I'm going to be totally honest with you. It's very rare that I sketch tangent and cotangent functions by hand, even in my life as a mathematician, right? So I think it's good that we kind of know how these work, but the chances that you'll actually be doing this is pretty rare. It's much more likely that you'll be sketching sine and cosine functions by hand, or using kind of the factors of sine and cosine and things. That's not to say that the tangent and cotangent functions aren't important. They very much are, but sketching them by hand, maybe on the lesser of the important factor. The big thing to remember is that with sine, cosine, tangent, cotangent, and as we'll see with secant and cosecant, sketching these really works the same way. We're going to find our period by taking the period of our original function and dividing by that horizontal factor, that horizontal multiplier. We can shift these horizontally by putting an adding or subtracting factor inside with the x. We can shift these vertically by putting an addition or subtraction factor outside. Usually we do that in front, so 2 plus the function, negative 2 plus the function. We can vertically stretch and shrink these the same way we could vertically stretch and shrink other functions by multiplying. And then we can x-axis reflect and y-axis reflect. All right, that was pretty quick, but hopefully that combined with kind of the more in-depth looking at transformations video is going to be enough to get us through.